Verifying the installation. Now we have installed the systems, we have played around with something, but let's write a simple TensorFlow script to verify that the installation is fine, and if there's any problems we can debug through it. Writing a simple TensorFlow script to verify the installation is a quick and straightforward way to ensure that TensorFlow is installed correctly and is accessible from your Python environment. Here is a simple TensorFlow script that you can use for verification. Import TensorFlow STF. Next, just create a tensor tf.constant hello TensorFlow. Next, start a TensorFlow session with tf.compat.v1.session ss. Run the TensorFlow operation to evaluate the tensor. Result equal to ses.run tensor. Print the result. Print result.decode. Now this is a simple script. I'm going to go over these details later, but save the script to a Python file, call it verify installation.py, and run it using your Python interpreter. The script performs the following steps. First, it imports TensorFlows, imports the TensorFlow library to access its functionalities. Next, it creates a TensorFlow constant tensor, defines a constant tensor containing the string hello TensorFlow. Next, it starts a TensorFlow session, initializes a TensorFlow session to run operations and evaluates tensors. Next, runs the TensorFlow operation, so executes the TensorFlow operation to evaluate the constant tensor. Lastly, prints the results, decodes and prints the results obtained from evaluating the tensor. Now running the script, navigate to the directory containing the script verify_installation.py or whatever you called it using the command line. Activate your virtual environment if you're using one, and then run the script using the Python interpreter python verify_installation.py. What is the expected output? If the TensorFlow is installed correctly, the script will print the message hello TensorFlow. Some of the troubleshooting that you can probably do is, if you encounter any errors, ensure that TensorFlow is installed correctly and accessible from your Python environment. You can check the TensorFlow version using print tf.__version__. You can verify that you're using the correct Python interpreter and that the virtual environment is activated if necessary. Refer to the TensorFlow documentation and installation guides for troubleshooting tips and assistance with installation issues. By running this simple TensorFlow script, you can quickly verify that TensorFlow is installed and functioning correctly in your Python environment, ensuring that you're ready to start working on machine learning projects with TensorFlow. If you have any issues, please leave comments below. Now, running TensorFlow in a Python environment. Running TensorFlow in a Python environment allows you to leverage the powerful machine learning capabilities provided by TensorFlow within your Python code. Here's a deeper look into how you can run TensorFlow in a Python environment. First, importing TensorFlow. The first step is to import TensorFlow into your Python script or interactive environment. This is typically done with a simple import statement, which we saw before, import TensorFlow STF. Next step, defining and running TensorFlow operations. Once TensorFlow is imported, you can define and run TensorFlow operations, also known as ops, with your Python code. TensorFlow uses a symbolic execution model where you define a computational graph of operations and then execute this graph with a TensorFlow session. For example, check this out. First, you define TensorFlow constants tf.constant2 and bstf.constant3. Next, you define a TensorFlow operation to add the two constants by saying add_op is equal to tf.add a comma b. Then start a TensorFlow session by saying with tf.compat.v1.session ss, result equal to ses.run add op, and then print the result by using the result variable that you used above. In this example, we define two TensorFlow constants a and b. We define a TensorFlow operation add op to add these constants together. We start a TensorFlow session and run the operation within the results using ses.run. So session.run. The result of the operation is printed. I guess it's 5, but yeah, you can try it out. Working with tensors. TensorFlow operates on tensors, which are n-dimensional arrays representing data. Tensors can be constants variables or placeholders, and TensorFlow provides a wide range of operations for manipulating tensors. One example is here, where you create a TensorFlow placeholder for 1D tensor of the type float32 by saying tf.compat.v1 placeholder tf.float32 shape equal to none. Next, you define a TensorFlow operation by saying share op is equal to tf.square of x, then running the session with the same thing that we did above, and then result you can just say sesh.run square op feed dictionary x is 1 2 3, then the result will be printed below. In this example, we define a TensorFlow placeholder x to represent a one-dimensional tensor of type float32. We define a TensorFlow operation square op to compute the square of the input tensor. We run the operation within a tensor session, provide input data for placeholder using the feed dictionary argument. Let me know how it goes. Next, using TensorFlow Keras. TensorFlow provides the Keras API, which is a high-level neural networks API that simplifies the process of building and training deep learning models. You can use TensorFlow Keras to create, compile, and train models with ease. Example, let's create a simple sequential model. So from TensorFlow Keras models, import the sequential, TensorFlow Keras layers, import dense, and then model equal to sequential, where dense units equal to 64, activation ReLU and input shape equal to 784. Next, dense units 10, activation softmax. Then compile the model using model.compile, optimizer Adam, loss square, sparse categorical cross therapy, and metrics is accuracy. In this example, we create a simple sequential model with 2 dense layers using TensorFlow Keras. Let me know how this works. We'll be doing more of these in future in the next few videos. So if you have stuck somewhere, don't worry about it. Just ignore this and we'll pick up right where you left. Now, running TensorFlow in different directions, you can in different environments. You can run TensorFlow code in various environments, including Python scripts, Jupyter Notebook, interactive Python shells, and production systems. TensorFlow provides flexibility and scalability to deploy machine learning models in different scenarios, ranging from prototyping and experimentation to production deployment. For GPU support, if you have a CUDA-enabled GPU and have installed the necessary CUDA toolkit and CUDNN library, TensorFlow can automatically leverage the GPU for accelerated computation, providing significant speedups for training deep learning models. If you have seen the previous video, you probably know what I'm talking about here. To conclude, running TensorFlow in a Python environment allows you to harness the power of TensorFlow's machine learning capabilities within the familiar Python ecosystem. Whether you're prototyping models, training neural networks, or deploying machine learning systems, TensorFlow provides the tools and flexibility to build and deploy state-of-the-art machine learning systems. A lot of you have had issues with the previous some videos. So what we've created is the troubleshooting common installation issues. So troubleshooting common installation issues with TensorFlow is essential to ensure that TensorFlow is installed correctly and functioning properly in your Python environment. Here are some of the common installation issues that people have been complaining about, and how do we troubleshoot that. First one is the version compatibility. TensorFlow may not be compatible with certain versions of Python, CUDA toolkit, CUDNN, or other dependencies. So what you have to do is check the compatibility matrix in the TensorFlow documentation to ensure that you're using compatible versions of all dependencies. Upgrade or downgrade dependencies as needed. If you need help, again, add in comments. Next one is missing dependencies. TensorFlow may fail to install or run due to missing dependencies such as CUDA toolkit, CUDNN, or other system libraries. The solution for that is install the required dependencies according to the TensorFlow installation guide for your platform. Ensure that all required libraries are installed and accessible from your Python environment. Next is installation errors. Installations may fail due to network issues, package conflicts, or other errors during the installation process. Check the installation logs for error messages and try reinstalling TensorFlow using pip or conda. Ensure that you have the necessary permissions to install packages and access the internet. A lot of times I use my office laptop and I am not on the network, so it will give me an error. but if I'm using my personal laptop, since I have full access on it, it doesn't give me error. So make sure that you have the necessary permissions. Virtual environment issues. TensorFlow may not work properly with a virtual environment due to conflicts with system-wide packages or incorrect environment configurations. So for this, double check that you're activating the correct virtual environment before running TensorFlow. Verify that the virtual environment has all necessary dependencies installed and that there are no conflicts with other packages. Next problem is for GPU support. TensorFlow GPU version may fail to detect or utilize the GPU due to driver issues, incompatible CUDA toolkit or CUDNN versions, or other GPU related problems. So what you have to do for this is check the TensorFlow GPU compatibility guide and ensure that your GPU is supported. Install the appropriate CUDA toolkit and CUDNN versions and verify that GPU drivers are up to date. Test GPU detection using TensorFlow GPU specific code. Next problem is with platform specific issues. Installation or runtime issues may arise due to platform specific factors such as operating systems, version, system architecture, or hardware configurations. For this, consult the TensorFlow installation guide and documentation for platform specific instruction and troubleshooting tips. Search for known issues and solutions specific to your platform or hardware. Also look at the video before that we did about installing TensorFlow on a particular system. Next is environment variables. TensorFlow may encounter issues related to environment variables such as path, LD library path, or CUDA home, which are required for locating dependencies. Ensure that environment variables are correctly set to point to the locations of CUDA toolkit, CUDNN, and other dependencies. Update your shell configurations files. In some cases it's .bashrc, sometimes it's bash profile, or sometimes it's zshrc to include necessary environment variable settings. Next problem is network connectivity. Installation or update of TensorFlow may fail due to network connectivity issues such as firewall restrictions, proxy settings, or unstable internet connection. Verify that your network connection is stable and that you have unrestricted internet access. If you are behind a proxy, configure proxy settings in your environment variable or package manager configuration. This is a very common problem with network connectivity. A lot of times people face this issue. So check your network connection properly and make sure that you have all the dependencies. Last one, documentation and community resources. You may encounter issues that are not covered in this list or TensorFlow documentation. Search for similar issues on forums, discussion boards, or community platforms like Stack Overflow. Consult the TensorFlow issue tracker for known bugs and workarounds. Reach out to the TensorFlow community for assistance and guidance. And if you still have problems, you can still leave me comments here and we'll try to get back to you as soon as possible. By following these troubleshooting steps and consulting relevant documentation and community resources, you can address common installation issues and ensure a smooth installation and setup process for TensorFlow in your Python environment. There will be more and more issues coming as and when TensorFlow evolves more. So you'll see some new issues, some old issues will be solved. But again, keep up to date and then it should work for you.